Hello friends, welcome to my channel. Let's have a look at problem 912, sort an array. In this video, we're going to share a treatment based on merge sort. So first I'll read through the problem statement and the requirements, and then we do the analysis, and finally we implement the merge sort algorithm from scratch. First, let's look at the problem statement. So given an array of integers called nums, sort the array in ascending order and return it. So we must solve the problem without using any built-in functions in logarithm m time complexity, and with the smallest space complexity possible. So here in this video, actually I didn't pay special attention to the space complexity. So here are two examples. So the first example, so after sorting, we are going to have 1, 2, 3, 5. And the second one, we are going to have 0, 0, 1, 1, 2, 5. The constraints for this problem are the following. First, the length of the list. So it has an upper bound, which is 5 times 10 to the power 4. And also the name elements in the list is bounded in absolute value by this number, 5 times 10 to the power 4. So with that said, we are ready to explain the merge sort algorithm. So the merge sort is one of the typical sorting algorithms. So its time complexity and is O n logarithm m, where n is the length of the list to be sorted. So the idea actually is simple. So the merge sort is a recursive algorithm that continuously splits a list in half. If the list is empty or of length 1, it's already sorted by definition. If the list has more than one atom, then we split the list and recursively invoke a merge sort on both halves. So once the two halves are sorted, so we just merge the two sorted halves to get a sorted result. So this operation typically is called merge operation. So the merge operation actually is a routine thing. The reason is that we typically write a lot of code, or it's just a very fundamental thing to merge two sorted lists and get an overall sorted result. So here, let's look at an example. So here we have a list which contains 4 elements, just for convenience. Then, because it has more than one element, so we're going to split in the middle. So we are going to get the left half, which is 54 and 26. The right half is 93 and 17. Then let's look at the left half. So it has more than one element. So we're going to do splits. So we get left and right. So left is 54 and right is 26. So both left and right have length 1 respectively. So both of them are sorted. Then we're going to merge the two sorted lists to get a sorted one overall. So we are going to get 26, 54. So this merge operation is very easy to implement, alright. So similarly, we have a right. So we do the split, we get 93 and 17. So their lengths are 1 respectively. So both the two halves are in sorted order. And then we merge the two sorted lists. So we get sorted right, that is 17 and 93. And then after that, we're going to use the two pointer method to merge the two sorted left and right. So we're going to have 17, 26, 54, and 93. So here in this problem, we're not allowed to use built-in functions. So let's implement this merge sort algorithm. So for that, let's make this merge sort algorithm a function. So merge sort. So it accepts a list. Here we assume that we have an integer list. So, and then we're going to first let's do the split. So we're going to check if the length of the list is greater than 1. If so, we're going to split the list. So we try to split into the by the middle. So we're going to get the middle as length of a list over 2. And then the left half is going to be a list, so up to middle, and the right half will be the remaining. Right. So this way, we finish the half as we explained in the idea. So we are going to call merge sort on both the two halves. So we are going to do merge sort. So for left half, and merge sort for right half. So once that's done, so what we're going to do, so here let's write. So this is the split. So this is a invoke and the merge sort. And next, so what we're going to do actually is a merge operation, right? So once we call merge sort on left half and the right half, then the right half and left half will be sorted. And then we're going to merge the two sorted half. So here we are going to do this in place. So let's initialize 3 pointers. So we have ij, so which is a pointer for the left half, the j is a pointer for the right half, and the k will be the pointer or indicator or index for the result. So what we are going to do is that let's first do the merge, right? So now left half and the right half are in sorted order. So then if I is less than length of left half and j is less than right half. In this case, here I'm using the add operation. So it means that both the two halves are not empty so far. Then we should do comparison. Then if left half I is less than right half j. So in this case, so we're going to set a list. The current one will going to be the smaller one, that is left half I. Then we're going to increment this I, right? So otherwise, so we're going to set a list k to be the right half j, right? Then we're going to increment j. So overall, after we set the current index k for the overall result, then we're going to increment k by 1. So after we exit this while loop, it's actually one of the two half must be traversed. So we have actually the longer one. So then we're going to add the remaining elements in the longer one to the result, or adjust that. So if I less than length left half, then we're going to do a list k, that is left half I. And in this case, we're going to increment I by 1, so similarly increment k by 1. So similarly, so we're going to do this, j if less than right half. So if this is the case, so we're going to set a list k to be right half j. So then we're going to increment j by 1 and k by 1. So actually, so after this first while loop, then we will enter one and only one of the while loops here, right? So with that said, actually we finished the merge sort algorithm. So here we do things in place. So now what we are going to do for this problem is the following. So first we are going to call merge sort nums, and then we just return the nums after we call this function. So this is a solution format for this problem. Let's first do a test. Yeah, it passes the first example. Now let's look at the second example. Yeah, it passes the second example. Now let's look at the generic case. Yeah, it passes all the generic cases. So I guess that's about it for this specific problem. So typically, this merge sort algorithm is one of the classic examples when we explain the recursion in coding or in programming. So here in this video, we explained a way of doing the current problem by using merge sort. Specifically, we implement a merge sort from scratch and then call this function and do the sorting in the problem here. So with that said, I guess that's about it for this video. Thank you.